So hey guys, so today we are back with another ML news episode. This is episode 4 and we are going to talk about some major things that happened this week. So to be honest, this week was a bit cold for the ML community. Not a lot of things happened this week, but yeah, we'll talk about what were the major news and what are the some new papers that have got into the market. So let's start with the, I think till the time I'm recording this video, this will be quite famous that so OpenAI has partnered with Stack Overflow. So what they are saying is that till now OpenAI maybe was not formally taking data from Stack Overflow, and now it will be taking. Now this is a bit not easy to digest thing, right? That OpenAI was not taking data from Stack Overflow. So if you look, so OpenAI will utilize Stack Overflow's API product and collaborate with Stack Overflow to improve model performance for developers who use their products. So maybe we can see a specific code generation model from OpenAI in a few months. Maybe let's see. And it says learning from as many languages, cultures, subjects, and possible ensures. So these are just things that are said from above, but everybody knows that OpenAI must have used the Stack Overflow data even before this deal. So yeah, I think it's like either you partner with us, we'll provide you some money, else we will anyway scrap all the data. So yeah, that is the thing. So yeah, that was it from the Stack Overflow side and OpenAI partnership that happened. Now let's move to the next news. So this week, Sam Altman is saying, and I hope you guys know that OpenAI is saying we will be streaming live on OpenAI.com at 10 p.m. Pacific time zone Monday, 13 May, to demo some Chat GPT and GPT-4 updates. Is this something new? So Sam Altman is saying it's not a GPT-5, not a search engine, but we are working hard on some new stuff we think people will love. Feels like magic to me Monday 10 p.m. So yeah, everyone is I think waiting for this. I think Google I/O was one event that people used to wait for the whole year to see some magical things happen, but I think OpenAI has taken that show away from them. So all we can do is do some predictions. Not GPT-5, he has already said. Maybe GPT-4's enhanced version, which is capable of doing some specific things that current versions are not. Else that GPT-2 chatbot that we saw, that was something I think we should be aware of, right? Okay, cool. Next is I think AlphaFold. So yeah, Google this week came up with AlphaFold 3. So they are saying that this predicts the structure and interactions of all of life's molecule. When they say all of life's molecule, they are saying DNA, RNA, ligands, proteins, and more. So yeah, what they are saying is that the current model can see at least 50% improvement compared with the existing prediction models. So yeah, this is a very good thing in the field of biology. And not only this, they have open sourced it, right? Anyone can go and start using it. So I'm not that good in biology, so I won't be commenting much on this because I don't have any experience working with these type of structures. So yeah, but open sourcing this thing and allowing users to go and test and see themselves how are the results it's really good. And I would personally say Google is working on solving some of the real life problems that are there, and AI can actually help improve the life of humans in such a way that we have not been thinking, like things apart from large language models. So they haven't told the AlphaFold 3 structure or anything. They have just told that what are the results and what are some use cases that they are mentioning. Else they haven't mentioned anything right now. So I'll link down if any one of you who is interested in biomedical science and everything. So you guys can go and try this on alphafoldserver.com. So yeah, now this week Hugging Face came up with the Intel came up with this low bit open LLM leaderboard on Hugging Face Spaces. So this is actually quite good, right? We can actually compare the 1 bit models and you can compare that. So you see uh, some 1 bit model are even able to get 62.43 on mmlu. That is a very good thing because till now having a specific leaderboard for 1 bit makes things interesting, right? Now people are actually going to look for that. Now this one I think was not specifically for bit, so we can adjust the precision here. Now if you look at the low bit contest LLM leaderboard, they will what they are saying in few days they are going to allow models which are currently not there in open source to be also present here. And if you see look at the citations, I think they have provided it. Yeah, so the I think the whole Intel team should be allowed to present this as a demo, because this quantized leaderboard was a must need for a lot of people. So you see here, right? I think right now the precision is, I think if I remove the 4 bit, it will be much better, because 1 bit models are also there. Okay, currently they haven't added that support, but yeah, it looks awesome, right? So if you see, if you compare the size and everything, you will realize that the models which are even close to 3 GB are performing really good. So if I remove the 7 and 13, you'll see. So you see the best result at MWS 66 point, that is 62. This is 5.3 mini 4K instruct. So 5.3 is definitely the best model in the market right now when it comes to under what you say 3 billion parameters, because I think it's exactly 3.5 billion, something like that. So we can expect 5 to actually outperform all the existing small language models. Yeah. So yeah, that was it for the this quantized leaderboard that I came across. Now some papers we should definitely talk about. The first paper is this XLSTM, that is extended long short term memory. So what is this paper actually saying? I'll give you a brief. It says that during 1990s, so this LSTM models introduced the concept of constant errors, constant error carousel, and gating, which became functional in deep learning. Right? We know about the LSTM architecture. Now LSTMs have been integral in various success, definitely. No, especially in LLMs, right? But the emergence of transformer, it has the parallelizable self-attention mechanism, and surpass, it actually outperformed LSTMs in all the things, right? In even scalability. So this paper actually introduces the question of how far the language modeling can progress by scaling the current LSTMs to billion of parameters while addressing their limitations. Now, these authors, they have said that they introduce exponential gating and modifications to the LSTM memory structure, resulting in two variants. The first, which they are saying, is the SLSTM, right? So this is with scalar memory and update, and the MLSTM with full parallelizable with a matrix memory and a covariance update rule. Now, if you look at the current structure, like this is the extended LSTM, far from left to right. They say the original LSTM memory cell with constant carousel and gating, and the second is a new SLSTM and MLSTM cells that introduce the exponential gating. So they say that SLSTM offers a new memory mixing technique, and MLSTM is fully parallelizable with a novel matrix memory cell. So if you look at the final one, so this is the XLSTM blocks, the memory cells they are saying, and this we have the new mechanism, the MLSTM and SLSTM. So yeah, that was it for the XLSTM paper. Now coming to the next one, we have the capabilities of Gemini models in medicine. So this paper actually was released around 10 days back, but I wanted to cover this. So as I said, actually, so Google is building things which are actually helping people in some real life mass level things, right? So this paper basically introduces the model Med Gemini. So it's a family of specialized multi models tailored for medical applications. They are saying that they're leveraging the strength of Gemini models in multi-model and non-context reasoning. So right, Med Gemini integrate. They are saying they have integrated web search and custom encoders for novel modalities. Now they have gone across several benchmarks. If you see here, right, so this is the benchmark they have gone across, and if you see right, so in all the previous SOTA models and the best GPT-4 method, Med Gemini is far better than the existing models. So when it comes to, and they are using all the capabilities, the multi-model understanding, long context processing, advanced text reasoning. In all of the cases, the current models are not even close, right? And the previous state of the art models are also not even close. Now if you see real world utility with novel applications, so summarization, doctor preference, referral generation, medical implications. So Med Gemini preferred, tied and expert preferred. So even in that cases, Med Gemini is actually outperforming the experts preferred ones, right? So if you look at the so on the Med QA, the most famous one, so Med Gemini is 91.1 and GPT-4 is 90.2. I don't see a very major improvement here. It's just, I think, 1% improvement. If you compare that from GPT 3.5, that is 60.2 to 91, yeah, that's a very big improvement, no doubt. And you see, right, multimodal medical dialogue, medical videos QA. So they are actually using it in some real life thing application, which can actually help a lot of people, right? And yeah, this paper is actually really good. If you look here, so the way they have done self training with the search, uncertainty guided search at inference. So even if the model is a bit not sure, it will definitely take the help of web. And yeah, this actually looks really good. So I would recommend you guys to see the capabilities that Google Gemini has used, the multimodal capability of having the image video thing along with the text generation thing. So that is really good. So yeah, that is it for the Gemini part. Now I think we'll move to the next paper, which is vAttention. So kudos to this guy. He has posted a video, like a LinkedIn post about the vAttention, and the way he has explained it makes it easy for a lot of people. So right now, you know, right, the concept about page retention. So this was introduced by VLLMs. Uh, uh, so if you guys don't know about VLLM, it's an inference a framework that is used for large language models. So the page retention concept was introduced there. And if you guys want, we can talk about that in a separate video, the page retention. And so what vAttention is. So currently the paper introduces a dynamic memory management system, that is the key value cache. So key value cache, I think you guys know, I recently released a video on key value cache. So uh, aimed at, you know, efficiently GPU memory utilization during inference, because training is one thing. We have frameworks like DeepSpeed, which actually helps a lot during training, right? And LoRa is also one thing that helps in training. Now while systems like page retention has definitely addressed the fragmentation issues by, you know, dynamically allotting the memory uh, in the fragmentation part, right? Now we need to look at some new concept, right? Because they introduce software complexities and inefficiencies due to changes in memory layout and the need for attention kernel rewriting. Now what vAttention says is that vAttention proposes an alternative approach that retains the KV cache in the contiguous virtual memory and leverages existing low-level system support for demand paging. So what how it is doing that is a separate case. But what is happening after this? So this is actually eliminating the need for explicit support for paging in attention kernels and avoids re-implementing memory management in the serving framework. That is a big thing, right? And so what the experiments they have done, the results demonstrate that vAttention achieves seamless dynamic memory management with unchanged implementations of attention kernels. You see here, right, illustration of memory waste due to the internal fragmentation. So they have even shown Orca that reserves memory for KV cache ahead of the time. VLLM, I think they have also showed, yeah, VLLM mitigates the fragmentation with dynamic memory allocation. So yeah, they have shown that. How are they even better than that? So what they are saying, this involves actually two layers of address translation. First, the framework tracks the virtual memory address of the KV cache block through block tables, and the second performs GPU virtual to physical address translation through the OS managed page tables. So it's a very good concept, right, for the inference. This can help a lot. Now if you look at the key contributions, you'll see that. So it's add dynamic memory management, evaluations with that using flash attention original. So optimizations that they have proposed, they are saying the same thing: internal fragmentation by small size page allocation, overlapping memory allocate with computation. So the results that they are saying, so they say for pre-fills it delivers higher throughput, outperforming page attention variants by 1.6 to 3.9x and 1.3 to 1.4. So that's a big number that they're saying, because VLLM is itself very fast right now. I think it's the fastest way to do inference, until you have a specific requirement that the input is long and the output should be short. Cool. So I think, yeah, that was it for this video. I'll link down all the resources in the description section as usual. You guys can go and have a look and read more about them in detail. So thank you and have a nice day.